To introduce our next speaker. This is Christoph Hauer from BOKU University, and he is the leader of the Christian Doppler Laboratory for Sediment Research and Management. Please start with your talk. Thanks.
Thanks, Gisela, for the introduction. So welcome, everybody. As it was introduced, I will talk and present about our CD laboratory for sediment management and research. This is a kind of 7-year research collaboration with the hydropower industry. And you now see a different picture compared to what we have seen over the last days, compared to the beautiful Swedish and Norwegian river environment. But this is also reality. So this is from the western part of Austria. A reservoir, a dewatered reservoir, and you see the huge amount of sediments when you compare the excavator and the people standing in this dewatered area to the amount which is deposited. And it was also stressed at the World Water Forum in 2003 that the last century was dedicated for building hydropower and building dams, but the 21st century will have the focus on the sediment management. And when we look on the hydropower in Austria, but also in other countries, we have two different concepts. So one is having reservoirs in the high altitude areas in the Alps, and we have the run-of-the-river power plants in the foothills of the Alps and in the river system itself. So two examples. One of the oldest is Kaprun in Austria for the storage power plants, and according to what we call run-of-the-river hydropower plants, Ybbs-Persenbreck at the Danube. And also the graph shows how hydropower installed capacity has increased over the years. So this red dashed line is indicating the Second World War, and after the Second World War, with the Marshall Financial Plan, the hydropower industry developed quite quickly in Austria. But since these power plants were in operation, we also have the situation that we have a continuous sedimentation, right? So in the high altitude areas, in the alpine areas, coming from the glaciers, coming from torrents, this continuous fill up with sediments. And also for the run-of-the-river power plants, due to agricultural land use, due to land use management in general, also the flood-protected regulation of our river systems, of the tributaries to the larger ones, and river incision, because the lack of sediment supply has the consequence that below the dams, rivers are incising, are also forcing this kind of a continuous deposition of sediments in the run-of-the-river hydropower plants. And this is a process which will go on, right? This is not something which will be stopped next week or in a couple of years or in a couple of decades, because we have the continuous lift-up of the Alps with about 1.6 millimeters per year. We have continuous bed erosion still at the Salzach River with about 7 centimeters per year. And we have soil erosion rates, which about 3.4 tons per hectare per year in Austria. But when you compare this to other European countries, like in Albania, where we also have research projects ongoing, we have totally different numbers. Like in Albania, we have 20 to 40 tons per hectare per year. And when we are now looking to Norway, where we are now, we have only 15 tons per square kilometer per year. This is a number from Jim Bogen. About the estimates of soil erosion rate. So a very huge diversity in the sediment supply to the river catchments and at least also to hydropower systems. And this needs to be figured out when we discuss this table. You may know this and you may have seen this. This is a prediction, a forecast which was made in 2010 about when about 80% of the reservoirs will be filled up by 80% with sediments. In a kind of global comparison on a continental scale. And the prediction was that in Asia, without any countermeasure, we will face this already in 2035. And for Europe, it is predicted for 2080. But there's a huge diversity, as I said, for Europe as well, comparing Norway and comparing Albania about the sediment loads. But this is all mixed up in these kind of numbers. Countermeasures. So we know there are technical measures to overcome this situation and get rid of the sediments, but it costs. And in Austria at the moment, when we talk about dredging and hydraulic dredging, it's about that we have to, or not we, but the hydropower companies have to pay 10 to 20 euros per cubic meter for extracting the sediment, and then it's waste from a legal perspective and has to put to some specific places for deposition, right? And this means 10 to 20 euros per cubic meter. And just remember the picture I've shown before. So we are talking not about a couple of trucks. So we're talking about 100,000 to million of deposited sediments. And then you add these numbers and you know what is the economical aspect behind these deposits. Then we have for sure the option for flushing, right? But flushing, as it illustrated on this picture, might be ineffective due to the cohesive sediment structure. It's also densely packed. So this means that additional maintenance work is needed, which means going out of operation takes longer than expected. So these are costs of 100,000 to million euros per just flushing event. And to get the permit, and now it comes to what we talk about sustainability and ecology, it's also sometimes that hydropower companies have to pay up to 100,000 just to get the permit in advance for ecological compensation, which will be later necessary. And we have the aspect of socioeconomic importance and costs. This is an example of the two floods at the Danube and the impacts on the Aschach reservoir. So this blue line is indicating this kind of deposition and getting a kind of more or less constant level of aggradation. And then we have these two cuts by the 100 years flood event, meaning the remobilization of fine sediments. And the follow-up was that along the entire Danube, we had the deposition in the gardens, we had the deposition along the river, and with huge damages, and the hydropower companies have been taken to court. So also additional costs. So this was all the reason why we established the CD laboratory in 2017, because we had a lack of information and technologies for the reservoir management, a lack of process understanding, so missing adjustment technologies for the reservoir management itself. Then the fourth point, very important, this interaction with the ecology. And also the fifth point is also from an economical point of view interesting about the reuse of the sediments of the deposited. So this is the scheme of the CD laboratory. We have 3 modules. In module 1, the entire hydropower companies of Austria are participating. And in module 3, we also had the turbine manufacturers, Andritz and Voigt, about the abrasional aspects. But this is not part of this talk. I just will focus on aspects for hydropower of module 1 and present some highlights, some results. I cannot present everything which was published over the last 6 years, but some things which I thought might be interesting. So one was that we used and established a technology which is well known in Norway about the gas and oil exploration, so the seismic profiling, just to detect the packing density of fine sediments and also to determine layer depth in reservoirs. And we were successful for fine sediment deposits in reservoirs. We were also successful for detecting thresholds between bed load transport and gravel substrate deposited and fine cements. But we had some problems in the rivers because also at the Danube, we just tried to establish this a kind of technology and tool to determine the amount of the gravel layer compared to a solid rock below, and this was not possible to use with this, to get these results with this technology. And we also use these core samples just for validation of these seismic pictures and creating this kind of 3-dimensional plots you see here, but we also use these core samples for laboratory studies because in the prediction of efficiency of flushing, for example, you apply mathematical modeling, right? About mobility, sediment transport mobility. But all of these equations have in common that the smaller the grain size, the less force is needed that the sediments are eroded and transported. But we know that for these cohesive sediments and for the very fine, this approach is not valid, right? So we have for the very fine sediments from the sand on to the clay fractions, so silt and clay, an increase in forces once again, and biofilm can even more create a certain stability on these fine sediment deposits. And we were successful in, with our laboratory experiments just to derive new equations for mathematical modeling concerning total mass erosion, initial erosion, and another criteria, so the initiation of motion. And this can be now used in the prediction and forecast for the efficiency of flushings. Then we had some experiments with tomographic PIB on turbulence effects on single grains, also to do some improvement, supported by numerical modeling. And then we had the problem in the past that with the physical scale models, turbulence phenomena cannot be addressed in a way that you overcome these uncertainties, that when it comes to implication of a certain measure, you do not fail or do not get serious problems later out of this. And we now have this new hydraulic facility in Vienna. There was the opening this Monday, where we can use up to 10 cubic meters per second as experimental discharge. And to avoid this risk of with two small scale models, and with the aim, the higher the selected model scale, the lower is the risk for unavoided errors in nature. So when we look now on this reservoir picture from the western part of Austria, and we just have these technical components in mind, we could say we have an improvement in the monitoring measurement technology established, coming up to improved process understanding, and implemented this improved process understanding into numerical modeling tools, which are helpful in the prediction of future measures. But what is happening downstream, right? So this is also very interesting. And now we came to the point of ecology and sustainability of those measures. We also have to look on this kind of existing threshold criteria. So in Austria, is that when you have a controlled drawdown of a reservoir or a flushing, that you are allowed to have 1 gram per liter as a constant load of fine sediments in the river. And then 10 gram for 1 hour and 5 gram for 6 hours. So this is the present status. But what you can see also, and in this analysis, that there's three-dimensional, or that suspended sediment transport is a three-dimensional process, right? So in blue, the areas with low suspended sediment concentration, and the same we talked yesterday about the hydropeaking and refugial habitats for hydropeaking. We also can identify this for suspended loads. And also like hydropeaking in the longitudinal perspective, we have a decrease in the suspended sediment concentration due to sediment deposits along the way, but also due to dilution from the tributaries. And the sediment deposits, for sure, this is what we know as clogging on the surface and within the interstitial. But clogging is not, from ecological perspective, a problem as long as the river has the capacity for turnover, right? If flood events have the capacity in alluvial channels just to move the sediments, the coarser sediments, we have this declogging process again. The problem is often that the rivers are forced to be a kind of plain bed with a pavement layer, and then the clogging becomes really a sustainable and severe ecological problem. Otherwise, these fine sediment deposits in the gravel matrix is a natural process which can also help a river to a certain extent. And I refer to this for the Vjosa River later. But here you see also that we have a kind of rarity in habitat-related suspended sediment concentration, like introduced before. People in the laboratory are working on this. In general, we have also to discuss some aspects that the rivers need to become more fit for more sediment, right? Because we have seen this amount of fine sediment deposits, and at the present state, we have a two-class society. We have the positive ones, this is the gravel. So gravel bars is, everyone wants to have it in their restoration project, and the lower picture with the fine sediment deposits, this is something which is negative, right? But both pictures have been taken from the Vjosa River in Albania, right? Just from different areas. And you do not go to Albania, you can also have this in the alpine areas, like for the Alpenrhein, these together, because also fine sediments have a certain ecological relevance for keeping the moisture, for our forest growth, etc. So here we have also the relevance of the fine. It's just the amount, right, for the river system which makes it harmful or not. So we have also now this kind of ecological scheme of improving monitoring, measuring, coming to improve process understanding, coming to some new tools. I have not presented them due to time constraints, but all in all, we have also on this side for sustainable sediment management made some important steps. Last point about the reuse, just one slide, because it's about an issue that for sure the first priority is that the sediments are for the rivers, right? So the sediments should be in the rivers as a backbone. But what is when the sediments are too much for the river system because of the existing boundary conditions? then we should think of a possible reuse. And one example of the crystalline catchments we are having, that in former days, when you go to Prague, the famous Bohemian glass was all made of this quartzite sandy material. And this is also something we had to stress. We have different sites we are studying, not only in Vienna. With our hydropower companies, we are investigating different case studies distributed in Austria, but this was not part of the CD laboratory, but we have also other research projects ongoing. We also went to Albania. Here you see the beautiful picture of the Vjosa River, and we were asked, when I move back, we were asked just to investigate what it would mean. There were 2 dams planned for the area of the Vjosa, Kalivac and Pocem, and we were asked, what does this mean for the river, based on a sediment perspective? And besides this prediction that within 30 years, 3 minutes, yeah, thanks, that within 30 years, the reservoirs will be filled up with sediments, it was also that we could see this kind of unusual concept of these Vjosa dams, because they use this kind of storage concept, which means a kind of capturing the catchment hydrology on an annual basis, on a daily basis, on a multi-annual basis, down to a large river system. And here we cannot capture these flood flows anymore, right? You have a frequent overspill, not the emergent overspill, but on a regular basis on the existing hydrology, because the turbines can only operate to a certain level if you want to have this in this kind of flood conditions. And meaning this kind of discharge over the threshold line is overspilling. And we have examples in a worldwide perspective, and I think this is a huge problem in general, because fine sediment transport occurs through the reservoir and over the dam, meaning that these kind of deposits are not occurring at the entrance into these reservoirs, but also very close immediately to the dam itself. And there's a case study in Albania. It's Devol. It's well known for having problems with sedimentation. And here you can see some pictures of the delta deposits in the Devol reservoir, and also about the lake deposits. And what does this mean in general for the Vjosa Delta in form of erosion? If you capture 80 to 90% of the sediment supply, is a huge amount of coastal erosion will occur. Will it be a follow-up? It's also a global problem, this kind of coastal erosion, but especially for Albania, we could show that the Albanian tourism, which is still under development and will be very important for the country in future, is strongly depending on the river sediments. You can see this on this picture, right? So from the rivers, the fine sediments, the sandy material is flowing along the coastline, preventing that from the sea, this coastal erosion is progressing. So meaning, and this was also what we were arguing to the ministry, you will have technical problems from the first year of operation. You will have also economic problems on the total country scale, because river sediments is something which is very important for Albanian tourism. So now coming to my last slide, so summary and conclusion. So I think sustainable hydropower must include sediment management, right? So from the economic, technical, and ecological perspective. So sediment management must be part when we talk about sustainable hydropower use in future. Sediments are a backbone for the river morphology. So there's the hydrology, there are sediments, and both together, the processes behind are forming the rivers and the habitats. So priority 1 is just look what amount of sediments is needed for the rivers. And in what form? Coarse sediments, like bad load transported gravel, and the fine sediments. So fines are also part of the natural system. Then a technical and economical optimization is possible and should be targeted. And the next point is also very important, just to avoid old-fashioned concepts. So this is what we have seen for this Balkan hydropower project. So from different companies, right? They just come with old-fashioned concepts from the 1950s, neglecting all of the knowledge we're having about these processes and disturbances of processes, and put them in place. And this must be incorporated as an environmental impact assessment, right? So what does this mean if you capture those sediments? Also giving numbers of costs for both the maintenance and the long-term run. And then to look what at the end it means, if this is still worth to build this power plant, yes or no. And there's still a strong need for basic and applied research and for scientific collaboration on this. And with this, I'm done. Thank you.